Hello, I'm Matt Woodlief, a solution engineer on Esri's national government team. If we look at climate change as a geographic problem that needs a geographic solution, there is no better tool than GIS. GIS provides the accessibility and context that leads to informed action. In terms of accessibility, take for example the most common format of climate data, the NetCDF. Using GIS makes this format more accessible by providing visualizations of the data. In fact, the NetCDFs can be directly ingested and displayed into ArcGIS Pro using a single tool, the Make NetCDF raster layer. Now that we've imported the NetCDF, we've quickly visualized the baseline for our global climate. The next step is to show how this is projected to change. That's an important word there, projection. These are not predictions, but climate projections, indicating that these numbers are based on actual measurements and developed knowing things will change. In climate science, these projections are modeled using representative concentration pathways, which measure the radiative forcing of greenhouse gases in our atmosphere in watts per square meter. Radiative forcing causes climate change by trapping energy as heat. For reference, RCP 1.9, or reducing radiative forcing to 1.9 watts per meter squared, was the goal of the Paris Climate Accord, stopping the warming at 1 degree Celsius. If we take no action and concentrations reduce naturally, we are looking at an RCP of 7, which is a rise of 4 degrees Celsius on average. We're going to use the GIS to look at RCP 8.5, the worst case, but still a very plausible scenario. This indicates a 4.3 degree rise on global averages, with some regions seeing a rise as high as 14 degrees Celsius. Turning on our RCP 8.5 layer, we get a sense of how climate could change globally. This shows that climate will not change equitably. It will warm faster at the poles, especially the North Pole. To get a sense of what global average temperatures could be, I'll use a built-in raster function to add the anomalies to the baseline. This function is the aptly named plus function, as I'm adding the values together. Here, ArcGIS is providing us a simple tool to help us understand complex climate models. We can see the temperature averages will rise globally, but with more intensity at the poles. We need to go beyond showing that climate will change. We need to show people how it will change. Most people understand there are specific types of climates, and this is something that we can key on. GIS gives us the tools to compare current climate conditions versus projected conditions. Let's look at the Mediterranean climate, a climate type most people know of, and is defined by dry, warm to hot summers, and wet, cool to moderate winters. According to climate models, this climate is going to change dramatically by the end of the century. The range of this climate is going to shrink, particularly in the oceanic areas. And looking at North America, California, which relies on the wet winters of the Mediterranean climate to combat the wildfires, is going to lose this source of fresh water. Other significant shifts on the Arabian Peninsula and in North Africa result in increased desertification due to the lack of precipitation and warmer, drier winters. This leads us to a great way to talk about climate change. It's not just that the climate is changing, it's the cumulative effects of that change that will truly impact people's lives. The last thing I want to share with you is this ArcGIS web application from the University of Hawaii, the Mora Lab, and Esri's Applications Prototype Labs. This app gives us the power to understand the cumulative effects of climate change anywhere in the world. We're using GIS to literally bring a global phenomenon home. So let's go to my hometown of St. Louis, Missouri. St. Louis is in the middle of North America, and people here need to know that climate change will affect them, even though we don't have polar bears, glaciers, or wildfires. Using this application, we can see that the climate disasters will strike here if nothing is done to combat climate change. Freshwater scarcity and drought is something that most people in Missouri have not had to generally worry about, and that is what's at stake. Through GIS, we can use the multidimensional tools to visualize scientific data, providing more access to this data. We can then combine those data sets with other geographic information for more context. But perhaps the most powerful aspect of using GIS is it gives you the ability to show, in a true sense, how a global phenomenon will have local effects. Bringing this information to the people is how we will drive action on climate change. Thank you.